Okay, for the past couple blocks, we've been talking about ocean water, and we know that life on Earth wouldn't be possible without water. Just about every biochemical reaction requires water in some form or another. So let's review. The ocean absorbs carbon dioxide from the atmosphere. Human activities, in particular fossil fuel burning, release carbon dioxide into the atmosphere. Too much carbon dioxide in the ocean has the potential to harm marine organisms and ecosystems. So between 1751 and 1994, surface ocean pH is estimated to have decreased from about 8.25 to 8.14. Remember, that is acidifying, but it is not acidic, representing an increase of almost 30% in hydrogen ion concentration in the world's oceans. Earth system models project that within the last decade, ocean acidity exceeded historical predictions. This could undermine the function of marine ecosystems and many ocean goods and services. Many marine organisms that produce calcium carbonate shells or skeletons are negatively impacted by increasing carbon dioxide levels and decreasing pH in seawater. For example, increasing ocean acidification has been shown to significantly reduce the ability of reef-building corals to produce their skeletons. Organisms must use more energy or make less hard part material. Existing hard parts will dissolve. The chemical reaction goes the wrong way. Today, more than 1 billion people worldwide rely on food from the ocean as their primary source of protein. About 20% of the world's population derives at least 1/5 of its animal protein intake from fish. Many jobs and economies in the United States and around the world depend on fish and shellfish that live in the ocean. Decreasing harvest could especially hurt the poorest people and the least developed nations that have the fewest agriculture alternatives. These challenges may influence migration. Block, go back. Today, more than 1 billion people worldwide rely on food from the ocean as their primary source of protein. Approximately 20% of the world's population derives at least 1/5 of its animal protein intake from fish. Many jobs and economies in the United States and around the world depend on fish and shellfish that have lived in the ocean. Decreasing harvests could especially hurt the poorest people and the least developed nations that have the fewest agricultural alternatives. These challenges may influence migration to more urban regions, which may lead to further social disruption and even conflict. Ocean acidification is expected to have negative overall effects in many marine species. This could alter the marine food chains and food supplies to humans. Acidification could also decrease storm protection from reefs, tourism opportunities, and other benefits that are difficult to value. First cell revenues from United States commercial fisheries totaled about $4 billion. Four groups of animals contributed almost equally to that total. Two groups are calcifiers, which means that they make shells, spines, or exoskeletons out of calcium carbonate. Crustaceans, lobsters, crabs, and shrimps, and mollusks, clams, oysters, mussels, scallops, and other non-crustacean calcifiers. The other two groups are animals that prey on calcifiers, like flounder and octopus, and top predators that eat the calcifier's predators, such as salmon and tuna. Of these groups, mollusks appear to be most vulnerable to direct effects of ocean acidification, but a decline in those species could cause problems for the predators above them on the food chain. Reduction in the fertilization of gametes in corals and other marine organisms, deformed flagellum in sperm that impacts their swimming. The fitness effect means that there's lower population growth in corals. Ocean acidification also reduces hearing ability in anemone fish, and particularly clownfish larvae. deformed morphology of calcium carbonate fish ear bones, or the otoliths, is a disruption of the acid-base balance in the neurosensory system. What happens? Well, there's lower survival due to higher predation. Tropical ocean predictions. Corals will become increasingly rare. Algae will become more abundant because coral reefs support so many animals. Biodiversity will also decline. And we see a nice healthy, we see it declining, and we see it dead. Non-calcifying algae. There'll be an increase of photosynthesis and growth. Lower pH means more dissolved carbon dioxide for photosynthesis and fuels their growth. The fitness effect would be higher survival and population growth. But as we know, that can be bad for the ecosystem. How do we know that the world is warming? What kind of evidence do we have? Well, measurements from satellites and weather balloons show that the lowest layer of the atmosphere, the layer in which we live, where airplanes fly and weather occurs, called the troposphere, is warming. Greenhouse gases are building up in this layer, trapping heat radiated from Earth's surface and raising the planet's temperature. Measurements over land and water show more water vapor in the air. The air feels stickier when it's hot, and air conditioners have to work harder for us to feel comfortable. Thermometers on ships and floating buoys show that the air near the ocean surface is getting warmer, increasing its ability to evaporate water. In turn, we see an increase in heavy precipitation events and flooding on land. Historical paintings, photographs, and other long-term records show that most mountain glaciers are melting away. People who depend on water from the melting glaciers for their living needs, crops, and livestock are facing potential shortages. This was the glacier in 1941, and this is the glacier in 2004. Tidal gauges and satellites that measure the distance from the orbit to the ocean surface both show that global sea level is getting higher. Rising waters threaten ecosystems, freshwater supplies, and human developments along coast, like ours. Satellite sensors and thermometers on ships and buoys show that the temperature of water at the ocean surface is rising. Warm surface waters can damage coral reefs, reducing opportunities for fishing, tourism, and leave the coast vulnerable to storm surges and erosion. Satellite images show that the area covered by sea ice in the Arctic is getting smaller. While a decrease in sea ice may open new shipping routes and provide easier access to natural resources, it may also introduce concerns related to national security and invasive species. So what are our solutions? What can we do about this? Well, we could reduce carbonate undersaturation caused by carbon dioxide dissolving in water. To counteract that, we would have to put in 2 gigatons of carbon to balance the equation. We would need 20 gigatons of carbon stop. Well, we could reduce carbonate undersaturation caused by excess carbon dioxide dissolving in the water. To counteract 2 gigatons of carbon per year input, we would need to add 20 gigatons of calcium carbonate. The White Cliffs of Dover would be rapidly consumed. Limestone rock, which is calcium carbonate, would be mined, and that mining is expensive and would cause ecological damage. All of the energy needed to move massive amounts of the rocks into the ocean would likely add more carbon dioxide into the atmosphere anyway. So, what might be a mitigation? Well, reducing greenhouse gas emissions or removing carbon dioxide from the atmosphere can lessen the severity of climate change impacts. We could use adaptation. It's also called preparedness. We could take action to minimize vulnerability to climate change impacts and can smooth our transition to a warmer world. We could develop new habits to eliminate wasted energy, switch to carbon free energy sources such as solar and wind, plant new trees to increase the amount of carbon dioxide, stop. We could develop new habits to eliminate wasted energy. We could switch to carbon free energy sources such as solar and wind. We could plant new trees to increase the amount of carbon dioxide taken up by forest. We could also adapt. We could protect habitat or structures threatened by sea level rise. We could develop plans to ensure adequate water supplies. We could plant different crops. We could develop new businesses. But what is the greatest idea? Well, yes, we could stop or at least decrease using fossil fuels.